I'm just solving one more. See the fifth one. Oh, factorization is not possible. Check up. It is not equation, so we can use quadratic formula. So what to do? There will be some such cases also where factorization is not possible, and this method does not seem to hold for the present example 3x square plus 4x plus 4 positive. What I am doing now, please watch. I have taken 3 common in the first 2 terms. I am going to complete the perfect square. X square plus 4 by 3x plus 2 by 3 whole square minus 2 by 3 whole square. This is added only to complete the perfect square. This will become x plus 2 by 3 whole square. Please see. A square plus 2ab plus b square. This is x square plus 4 by 3x plus 4 by 9 perfect square. Now the question arises, a basic question arises. Many times students get confused how to write this 2 by 3, how to come to this 2 by 3 whole square, or how to complete a perfect square. Learn it here completely, perfectly and forever. How to complete a perfect square, because you will be needing such things anywhere in mathematics, particularly in integration. You may have to complete perfect square so many times. How to complete the perfect square, you learn here. See here. In 7th class, there were such questions. What is to be added to x square plus 10x to make it a perfect square? I repeat, what should be added to x square plus 10x to make it a perfect square? What should be added? We have to find out how to add and what to add. Please see here. Take half of the middle term, square it and add. This has become perfect square. So once again I am telling you the method of completing perfect square. Half of the middle term whole square. See one more example. What is to be added to x square minus 7x to make it a perfect square? Method is the same. Half the middle term whole square. Please see here. Add 7 by 2 square. This has become a minus b whole square. X minus 7 by 2 whole square. So how to add for making a perfect square? You have seen 2 examples. Many more examples will come at that time also. I will once again explain in detail this only. Now let me proceed. I have added 2 by 3 whole square, compensated also. Continuing the same work, please see once again. 3 times x plus 2 by 3 whole square minus 3 into 4 by 9 plus 4. Last part outside the bracket. Positive, you can write positive still, no problem. This part, generally students don't ask, but I explain always. Minus 4 by 3 plus 4. That's why removing minus 4 by 3 plus 4, I wrote plus 8 by 3. Even sometimes small things confuse. That's why I have made that also clear. Now, what is the question? Question is 3x square plus 4x plus 4 to be positive. Please note here, this is a perfect square. It is always positive irrespective of a minus sign here or plus sign. A perfect square is always positive. Please remember my words. Whether it is x minus 2 by 3 whole square or x plus 2 by 3 whole square, a perfect square is always positive. So this part is always positive for any value of x. You take x is equal to minus 20, x is equal to plus 20, whatever you value you take for x, being a perfect square, this results in a positive quantity, plus 8 by 3, another positive quantity, entirely positive. So this expression becomes positive for any real value of x. X must belong to any real value. This is the answer. This is the answer for your question. I want to solve one more, the 9th. Solving, please see. Factorization, please see. Factorization. Understand factorization of trinomial. I don't want to explain factorization at this level. Should you need, you can ask again, we'll see. But at this level, I don't want to explain how I got plus 9 minus 5 and all that. This is not the level to explain that minormost thing. I am solving one more example. 15 plus 4x minus 3x square negative. Proceed. Factorization. Three common. X common. 5 plus 3x common. (15 plus 4x minus 3x square) has been factorized. Now question comes of intervals. 5 plus 3x is equal to 0. Please see the rough work once again. 5 plus 3x is equal to 0 gives x is equal to minus 5 by 3. 3 minus x is equal to 0 gives you x is equal to 3. So I have to mark those numbers on the number line. Minus infinity to infinity or plus infinity. Minus 5 by 3. 5 by 3 is, please note, 1.2 something or 1.1 something. It is like that. So it is here minus 5 by 3. and plus 3. In between 0 comes, let it come. I am not marking, I don't need to mark. I have to mark only my values minus 5 by 3 and 3. I have marked properly minus 5 by 3 and 3. Please see here the intervals are minus infinity to minus 5 by 3, minus 5 by 3 to 3, and 3 to infinity. For x belonging to the first interval, x belonging to the first interval minus infinity to minus 5 by 3, take any number this side. You can take minus 2, minus 3 because this is minus 1 point something. So you can take here minus 1.5 or minus 2 or minus 3. Let us take minus 3 here. Substitute here. Assume any value in this interval. This is minus 4, this is plus 6, giving you negative. Proceed. Next interval. In this interval 0 comes here, conveniently take 0. This is 5 into 3, positive. Last interval. Take 4 and substitute here. Negative. My question is also negative. So the first and the last. For x belonging to the first interval up to minus 5 by 3 or the second interval from 3 to infinity. 3 to infinity, this interval it is negative, minus up to minus 5 by 3, this interval it is also negative, and we require negative these two. So this is the answer. Before concluding, I want to tell you once again, whereas quadratic equations give you the exact value of the variable, namely x, the quadratic inequations give you the intervals to which x should belong.